Hiya. So for this problem, we're going to look at question 2 from the practice exam for exam 1. So let's kind of break this down and see what is happening here. So first, let's look at this question. Every morning, so this is kind of some info. We're doing this every morning. You walk into a coffee shop and you get some coffee. Some days, you decide to treat yourself to a pastry. So here I know that there's going to be some probability measure, right? I'm not getting a pastry every single day. And in fact, the next statement tells me how often. You decide to treat yourself with probability 1/5. So 1/5 of the time, I'll treat myself with a pastry. After going to the coffee shop for 2 weeks, so 14 days, what is the exact probability that you get a pastry exactly 3 times? So basically, this is the question. So you go 14 days, what is the exact probability that you get pastry exactly 3 times? So what do we have? We have probability to treat oneself is 1/5. Number of trials, how many times do we try things? This is our n, right? So this is our p. Our n, this is given by how many times we go. So we went 14 times. 14. This is our n. Since we went 14 times, since we went to the coffee shop 14 days. And then we need to know the probability that it happened exactly 3 times. So the event gotten 3 pastries implies k is equal to 3. So here, well, therefore we want to use the binomial distribution. Right? Because we want the exact probability, so we're going to use the binomial distribution. Let me zoom in a little more. So what is the binomial distribution? So the probability of getting 3 pastries, which a lot of times we'll write this as the probability that k is equal to 3, right? We're saying when is k equal to 3. This is given by n choose k, p to the k, 1 minus p to the n minus k. You don't have to write this formula out, but I would recommend it to help the graders make sure that you actually know what you're doing. So I would definitely write this question. If you have anything with binomial distribution, you should definitely write the formula out, just like we did with Bayes' rule and law of total probability. So here we'll say binomial distribution. So this is equal to, at this point, we just plug in numbers. So we have 14 choose 3. 1/5 to the k is 3 here. 1 minus 1/5, this is 4/5. Something like this I'm okay with you doing right away. 14 minus 3 is 11. So what do we have? We have 14 factorial divided by 3 factorial times 11 factorial. On top we have 4 11ths. On the bottom we have 5 to the 14th. I can quickly cancel some of these things here, right? These go away, and I'm left with 14 times 13 times 12 over 3 times 2 times 4 to the 11 over 5 to the 14. At this point, again, you're probably going to want to use a calculator. You can also use a calculator earlier for 14 choose 3. That's okay. And then we end up with 364 for this first part. And the second part is given by some nasty formula. So if I do this correctly, I should get this number. And then multiplying these two out, I get 0.250139. So roughly 25% of the time. I guess you should add a little more notation, so 0.101%. So you should add this. So this part is the part you put on E-class. Either this or this, one of the two. Again, the more decimals, the better. And then everything else you would put, so all of this you would then grab and put into CrowdMark, so that I can see that you know kind of what you're doing. And that's it for this question. So I will see you in the next video for question 3.